Hi, my name is Brandon Gracely. I'm a high school math teacher, and today we're going to look at how to graph parabolas using first differences. So we're going to start off with the basic, most common parabola, that quadratic y equals x squared. I'm going to make a quick table of values here. And I'm going to start with where x equals 0, y is 0 squared, which is 0. When x is 1, y is 1 squared, which is 1. X is 2, y is 4. X is 3. Y is 9, x is 4, and y is 16. We'll do one more, 5 and 25. So what I want you to notice here is as x goes up one at a time from 0, 0, the vertex of this graph, there's a change in y. Y goes from 0 to 1, so that time it's going up by 1. But then, as x goes up by 1 more, y goes up by a different amount. It goes up by 3. And then here, from 2 to 3, y is going up by 5. From 3 to 4, y is going up from 9 to 16, which is 7. And then the last one that I've written here is going up by 9. And so do you see the pattern here? Each value here is increasing by 2 each time. To say that again, y is going up by 2 more each time than it did the previous time. It goes up by 1, 3, 5, 7, 9, and the next value is going to be going up by 11, which is 2 more than 9. 11 plus 25 is 36, which you can see is 6 squared. So that's the pattern. We can use this feature of these graphs when we are plotting points or when we're graphing them. So here I've got some axes. There's 0, 0. When I go over to 1, I guess I should write a little bit on here. 1, 2, we're not going to get too much on this graph. 1, 1, and then I'm going to go over 1 and up 3 this time. You can see I get to the point 2, 4. Then I go over 1 and up 5, which is actually off of the top of this graph. I'm going to do the same thing on the other side, the mirror images of those points. And I'll connect them up. Let's go with purple. So there, let's get a nice curve here at the bottom. There's my parabola. It continues on. And if I were to continue, I would go up by 7, and then 9, and then so on with the remaining parts of this curve. So what that means is that if I know where the vertex of a graph is, that of a parabola that has a sort of a normal shape where there's no value in front of the x here, where the coefficient is 1 instead of like 3 or something else, if I know where the vertex is, I can plot the same points with that new starting point. So let's say, for example, that I have a parabola. Let me move this over here a little bit. Let's say I have a parabola with a vertex, I don't know, down here. So if that's the vertex, which is negative 2, negative 2, then I can plot the remaining points using my pattern. I go over 1 and up 1, over 1 and up 3, and then 5, and then so on if necessary, as much as I need to on this graph, and the mirror images on the other side. So whatever the vertex is, I can use my step pattern to graph the remaining points starting from that point. Okay, so if you know the vertex, use the step pattern to graph your parabola.